Welcome, everyone, to our second episode of Architecting Data Strategies with YugabyteDB. My name is Michael Haig, and I'm thrilled you can join us for our next episode of this new on-demand video series. Now, these discussions are designed for IT architects and anyone else that influences how your organization handles data or is responsible for architecting changes that leverage data or the database layer. Today, we're going to have two great guest speakers join us. I'm thrilled to be joined by two seasoned database veterans and members of the YugabyteDB worldwide field engineering team. Don Bizzell and Brian Jimerson, welcome to you both. I'm excited that you could join us for episode number 2.
I'm Brian Jimerson. I'm a field engineer with Yugabyte. So I've been in this field for well over 20 years, ranging from application development to platform engineering and database.
I'm Don Bizzell. I'm also a field engineer here, based in Dallas. I've been in the database industry now for 30 plus years, and I'm really excited to talk to you today about events and streaming.
Awesome. Thanks again for joining us. All right, let's get to the topic at hand. So we're here to talk about event and data streaming. Now let's take these first few minutes. We'll do a quick overview of the topic and why it matters. And then we want to jump right into the architecture details. And more importantly, we'll look at some real world examples. So I'm excited to hear about some real world stories out there. I know you have a great talk lined up, so let me get out of the way and I'll turn over to you, Brian and Don, to run with it.
Thanks, Michael. So let's talk a little bit about what streaming data is. I'm sure a lot of people have different definitions, but in the context of this session, streaming data is really a continuous, unbounded, meaning there's no beginning and no end, flow of data. And this data can be from numerous different sources. Typically, this data is aggregated in a processor. It's captured in discrete packets or events. And then the aggregate data is then stored somewhere to provide business value. The event streaming or streaming data really allows organizations to process data in near real time, if not real time, and act upon that data immediately with action.
Now, streaming data has been around for a long time. Data has been coming off of things, but typically it just gets thrown away. If there's something out of bounds, it gets acted on right away, but then there's no storage. What's new here is the ability to store that data and get a lot more value from it. So there's a lot of use cases that applies to.
So what are some of the typical use cases that streaming data or event streaming, we use those terms interchangeably. What are some of the use cases that this can be applied to? And really just about any industry has use cases that can realize value from streaming data. Some popular examples are things like customer or user activity, being able to capture and act upon data generated by customers. This allows companies to engage with customers much, much better and analyze their behaviors in different systems. IoT and sensor data is another very popular one. The explosion of the Internet of Things in both commercial and consumer markets generates massive amounts of data that need to be distributed across the globe and acted upon almost immediately. In the financial arena, there's stock and financial metrics that are generated in nearly real time and again, massive amounts of data. So real-time analytics of stock behaviors, for example, is becoming very popular. And, even in the retail sector, inventory management. So having real-time insight into, what your product inventory is, whether it's on the shelves or in a warehouse. You can really reduce the overhead of having on-hand inventory and even mitigate risk from theft and fraud.
Now, this data really comes in regular streams, like sensor data every 5 seconds, every 15 seconds, or irregular, like somebody going to an ATM machine and making a transaction, right? They're always happening. It's just they're not regular every few seconds. So both those types of data require different types of structures in the database. Some are best set for NoSQL, some are best set for SQL. So you're going to see how Yugabyte can help you with that in both sides.
So what are some of the benefits and why are companies adopting event streaming or streaming data systems? And there's many of them out there, but it really changes the paradigm about how data is consumed by businesses from, waiting for batch jobs to run overnight or during a week and analyzing that data to having near real-time in order data available to business to make these real-time decisions. It also allows them to be proactive in determining thresholds and when they might be crossed and driving those outcomes. So, really this event stream processing allows users to process massive amounts of data from streaming events, kind of analyze and aggregate that data in flight and respond to changing conditions in the market or in the business. You can continuously monitor conditions and interactions with your products and even detect patterns and sentiments changing over time.
And now that you're able to store that data over a history and have a history of time, you can see trends, you can see other things you can analyze. You can even have data that you can then monetize on further down the line and create new lines of business with your data. So this data now becomes very valuable to the organization, as opposed to just, is something in bounds or out of bounds, or did something happen? This way you get more benefit from it than just having the data.
So as with any new technology or new pattern or system, there's obviously a lot of challenges with implementing a real-time event processing system. So, just a handful of the difficult challenges that people are encountering. One of the biggest ones is that the current databases and frameworks that people have used over the last however many years just aren't really well suited for the speed and scale required for processing event streams. The consistency that's required and the transactional consistency and ordering are difficult to achieve in a distributed real-time system just because of the speed and volume. And these systems need to provide parallel processing to process the amount of data, as well as fault tolerance, high write throughput, resiliency, and all the other qualities that are required from a mission critical system.
We've got a great example of that coming up in just a few slides. But one thing I wanted to mention here was the definition of real time. For some use cases, real time is actual real time, and that requires a whole different level of world, right? If you're doing automotive real time things that, how much fuel do I inject into the cylinder right now? That's a different kind of use case. But for most data streams like this, real time is 5 seconds to anywhere to 15 minutes to an hour, even, just depending on what the data is and what type of usage you want to have from it.
So what does a modern data streaming system look like? We've kind of presented this in a simple fashion, and we'll look at some more complex real world examples. But just to kind of describe what it looks like, there's really 3 major components in this event processing system. So there are the event sources, and these event sources can be anything that generates events or data that the system is interested in. There's an event processor. So this event processor is responsible for ingesting this data, for processing this data in some with specific business logic and storing that data. And then there's also an event consumer on the far right here. And these event consumers are any systems outside of the processing system that is interested in this event data or the aggregate from that data. So if we kind of walk through this a little bit, on the left-hand side, these event sources, these can be anything that generate events. And some common examples are smartphones and tablets and wireless devices that are generating, location data or other types of data. It may be IT systems like firewalls or logs or, routers, things like that. IoT devices such as smart home devices or telemetry data from a vehicle, which we'll look at a little bit closer. Cell phone towers, plant equipment. Again, the number of sources go on and on and on, but these all generate, streaming continuous flows of data that are interested in. And then kind of the middle 3 boxes here, this is the core of our event processing system. This is the event processor that ingests data from these event sources. It processes, it cleanses, and it aggregates this data. And then ultimately it stores this data into a persistent storage unit. And this, what we're going to show is how YugabyteDB is perfectly suited to be the storage for both the real-time event sources as well as any of the aggregate sources that are generated from the processing system. And finally, the event consumers these are upstream applications, and these can really be anything that is interested in the results of this stream processing and even the raw data. So these may be APIs that are exposed to third parties. These may be mobile applications that react to real-time events. Anything that wants to use this data in a meaningful way can.
And It's also important to be able to process JSON and flexible schema type information here. Say you've got a factory and you've got 20 different types of machinery in your factory, and they're all generating statuses, but all of their statuses are slightly different. You don't want to have 20 different streams for each machine. What you want to have is a stream for that factory that comes into your architecture as key values and maybe a JSON, and be able to process that JSON in the database fully by your real-time applications. So that's an ability we're looking for here from the database.
And so one layer to add on top of the obvious complex stream processing system is that oftentimes these event sources are located in remote locations. So for example, plant equipment or point of sale systems in a store. And there's a lot of benefit to be able to process these streams locally at the edge, and then ultimately send the aggregate data up to a consolidated cluster that can be used for analytics or further processing or whatever else is required. So for example, you may have plant equipment that's generating telemetry data in each of your plants, and you have a small Yugabyte cluster and stream processing system running in each plant that is responsible for processing its local data. And then using Yugabyte's replication mechanisms, both synchronous and asynchronous, you can replicate that data to a consolidated Yugabyte cluster that can then be fed into other systems.
Yeah, this uses mostly the asynchronous mechanism to get from cluster to cluster, and it's primarily a feature of the SQL, the SQL part of our database. And this ability is fairly new, and it's a very exciting way to gather data from multiple places into a single consolidated system and have it act as a single table across all of your different edge areas. So this gets you into a different type of architecture that allows you to really bring that data together and use it as though it were one single table, even though each individual remote has its own set of tables.
So let's take a look at a few Yugabyte customers and how they're leveraging Yugabyte as their storage tier in their event processing systems, and how it really drives business impact for these. So the first one we wanted to talk about is GM, General Motors, a very large Yugabyte customer. They have over 20 million vehicles, and it grows every year on the road. That it's generating massive amounts of telemetry data from those vehicles, and they then use that data to support other business units, to expose to partners, both external and internal, and it really drives a lot of revenue for GM. So they have very large systems. So they have over 3 million writes per second for the data coming in from these vehicles, over 70 terabytes of data stored. They only store it for 90 days in hot storage. And they were struggling with both performance as well as kind of day two operations like upgrades and scaling with their initial solution, which was Apache Cassandra. And so they since moved to YugabyteDB and have really realized the value that Yugabyte can bring in a system of this scale. So they are able to scale during peak times. They were able to scale 10 times faster from what used to take them, a couple of weeks to scale to what is now a day at most to scale out or scale in. They've improved performance over 10 times better, and they've actually, ironically, they save so much because of the data density that Yugabyte provides compared to Cassandra. They were actually able to reduce their hardware footprint, and the savings in that more than paid for their Yugabyte licensing.
So that's a great example of being able to take a data stream that was just streamed that didn't do much for you, save that data, be able to look at that data and have more business value from that data afterwards. I mean, this is a perfect example of that.
And this slide shows kind of the high-level architecture of this system at GM. It's called Vehicle Data Factory or VDF, but it should look pretty familiar to our more simple architecture diagram. It definitely aligns with that general architecture. So you can see they've kind of created four pillars of functionality. So they have their messaging tier. And this is actually using Apache Kafka as a message bus. And this is the tier that ingests data, telemetry data from vehicles. It exposes data back out to partners that want to consume that data, as well as events that are generated by your mobile application. And then they have a transformation tier that's built on Apache Spark Streaming. And this transformation tier, takes the data that's being ingested from vehicles. It does transformations in various forms and various stages, and it ultimately stores the output of each of those stages in YugabyteDB. So YugabyteDB is the system of record for all of this data for GM, and it's stored there for a period of days and ultimately offloaded to cold storage in Hadoop for historical purposes. And then Yugabyte also serves as the system of record for what they call their edge applications, or the consumers of the applications. And these are all sorts of different business units, APIs, and it even drives their mobile applications. So for example, if you have GM's mobile application and you want to lock your doors, that generates an event that is then streamed back to the vehicles. So it's not just vehicle data that's driving these events, it's also interactions with their end users.
That's a really exciting area. And they do some in the transformation layer, don't they also do some aggregations and
They do.
other work there?
They do a lot of aggregation. Now in the transformation layer, I've kind of abbreviated these since that's proprietary GM naming, but there is some transformation, there is aggregation of data, there's obviously calculations that are done, there's all sorts of processing that's done.
Now this is GM setup, but this is just fairly generic. Any architecture that you have is going to fall into something very similar to this, or have another extension if you're doing consolidations. So this is very close to what an architecture should look like for this type of streaming event, whether it's on site or in the cloud, because this can happen in both places.
The next customer I wanted to take a look at is Plume. So Plume is a management company for consumer Wi-Fi devices, as well as smart devices that are connected to these Wi-Fi devices. And so they are really a management plane for all of the connected homes and smart homes that are out there that have purchased these devices. So obviously this generates a lot of data. If you think about the number of consumers out there and in each household, how much data they generate, that's really billions of operations per day. And their data set is currently around 35 terabytes and growing. And so they were also struggling with a number of challenges with some of the data store solutions like Mongo that they were using and Cassandra, but again, really struggled at scale. And so they brought in YugabyteDB and were able to achieve all their business goals, including data sovereignty compliance by geopartitioning their data to keep it in the locality that it needed to be in.
So not only can we consolidate data, but we can also keep the same table separated geographically using a very similar mechanism. So records that have an EU code go to the EU data center. Records with a US state code go to the US data center. Records with a California code go to the California data center, etc. So you can meet all these various security requirements.
And then the last customer I wanted to take a look at is Xignite. So Xignite handles stock ticker and financial market data as a back end for many of the major financial companies in the US. They obviously have requirements of very low latency, very high transaction volume, because they are the backbone for these financial companies. They have very specific SLOs and SLAs. And they had originally started with AWS RDS service as well as Redis for their database solution for the streaming data. And again, they were struggling as well with day two operations, with the high transaction volumes, the low latencies that were required. And they even tried to implement some caching solutions to help offset some of the performance issues they were having. But again, it wasn't really acceptable performance that they were getting from that. So they've since implemented YugabyteDB. They've achieved all of their operational goals and performance goals. They've achieved a lot of savings, about 50% compared to AWS RDS, and they have a global footprint of Yugabyte in their stream processing.
Now, if you've got a car and the engine temperature doesn't get back to GM this 5 seconds or 15 seconds, no one really cares, right? You'll get another one, you can average it out, it's easy enough. You get a financial transaction, you need to make sure that financial transaction is absolutely consistent all the way through the chain, and that its values are all set in the right order and so forth. Doing that at a large scale with a SQL database is pretty difficult, but not anymore, right? And that's why we have so many financial industry customers coming to Yugabyte, because of that high consistency throughout, even though they can scale and have the resiliency that they're looking for.
So there's a lot more that we could cover on this subject. It's obviously a very broad subject, but there are a few things I wanted to leave behind as key takeaways. So I think the first piece is that real-time events are a very valuable data source for companies. They can increase their customer success, increase revenue, and a number of channels. But the current database solutions that are out there really aren't appropriate for whatever made to support a real-time streaming data system. So the data solutions or data streaming systems need to be able to support, horizontal scale, extremely high write throughput, strong consistency for transactions, and also provide resiliency. So the good news is that YugabyteDB provides all these things for you out of the box. It provides the scale, the throughput, the geo distribution, and so on. And that's really what Yugabyte was made for, to provide those types of things. If you're interested and want to talk more about that, I encourage you to reach out to us, and we'd love to have a discussion.
Don, Brian, thank you so much for joining us today. This was a great walkthrough. Exciting to see more and more of these architecture patterns, leveraging distributed SQL, seeing how YugabyteDB connects with the rest of the ecosystem, those other pieces that are important. So to both of you, thanks for joining us today.
Thank you.
And to all of our audience out there, thank you for joining us for our second episode of Architecting Data Strategies with YugabyteDB. If you want to learn more about how YugabyteDB can help, or you want to discuss these architecture patterns, you can email us at sales@yugabyte.com, or you can reach us on Slack at any time. And don't forget, check out our first episode on systems of record. It's available online today, and we look forward to seeing you back here for our next episode. Thanks for joining us, and we'll see you here next time.